Hi everyone. So this lesson is about all different ways to measure segments. So remember, a segment is a piece of a line that has a beginning and end. So there's all different ways you can measure them. We're going to learn about Pythagorean theorem, which you should have already learned about in middle school. And then we're going to learn something called the distance formula, the midpoint formula, and then something called segment addition. All right, here we go. Okay, so the first thing we're going to talk about is Pythagorean theorem. This is something that you should have learned in middle school, like I said. But we like to review it because it's used a lot throughout geometry. And so we review it now so that way when it comes up here and there, you'll remember it. So this right here is Pythagorean theorem, a squared plus b squared equals c squared. Now to determine which pieces of the triangle are A, B, and C, if you guys remember the hypotenuse, which is here, is always your C. It's across from the right angle. Then the legs, which are here and here, are A and B, and it's interchangeable. It doesn't matter which one you say is A and which one you say is B. So I'll say this one's A and that one's B. Those are the legs. And so we're just going to do a few examples. Hopefully once you see it, you'll remember it. Let's see. Here's our first one. So the first thing that you want to do when you're doing Pythagorean theorem is you want to determine what is your A, your B, and your C. So this is my C because it's across from the right angle. And then I can call this A and this B. But again, I could have swapped that and said 3 was A and 4 was B. So then you just plug it in. So this is going to be 4 squared plus 3 squared equals C squared. Then you square the numbers. So 4 squared is 16. 3 squared is 9 equals C squared. Then we're going to add these two together. So that's going to be 25 equals C squared. And then lastly, you take the square root of each side. So C is equal to 5 because the square root of 25 is 5. Okay, so that's our first example. Our second one, again, you first want to identify your A, your B, and your C. So here is my C. I'll call this one A and this one B. So we're going to have 6.3 squared plus x squared, or you can say b squared. It doesn't matter if you say x or b, equals 15.4 squared. Okay, then you're going to square 6.3 and 15.4. So 6.3 squared is 39.69 plus x squared equals, and then 15.4 squared is 237.16. Okay, now we need to solve for x squared. So I'm going to move this over to the right-hand side by subtracting. So I'm going to subtract 39.69. So we're going to have x squared equals 197.47. And then the last step, we're going to take the square root of both sides. So x is approximately 14.05. So that's another example of Pythagorean theorem. Okay. The next thing we're going to talk about is distance formula. So if we have to find lengths of segments on the coordinate plane, remember coordinate plane is like x and y axis, right? The Pythagorean theorem actually leads to something called the distance formula. So distance formula, again, is something that's sort of used a lot throughout geometry. This is the distance formula right here. It is something you'll have to remember at some point. Basically, you're given two ordered pairs. So say here's one ordered pair, here's the other ordered pair. We call them x1, y1 and x2, y2. They're just labels for the numbers, so that way you know where to plug it in. And so you plug in the values, and then you simplify. So I think once you see an example, you'll see it's pretty easy. Okay, here's our first example. I wrote out some steps for you too. So the first thing we're going to do is identify these ordered pairs. So I have x, which is at -2, 0. And I have y, which is at 3, -5. Okay, once you identify your ordered pairs. Now, sometimes you'll just be given the ordered pairs, but I just wanted to do a few different types of examples. So once you get your ordered pairs, I would suggest to label your points with x1, y1, x2, y2. So I'm going to say that this one is my first ordered pair. So this is going to be x1, and this is going to be y1. This is going to be x2. And this is going to be y2. So remember, I'm just like labeling it to say like, this is my first x and y. This is my second x and y. I'm going to rewrite the formula right here so we can plug it in right underneath it. I would suggest that you guys do too. That way you just remember it after a while of just continuing to write it. Okay, so now I'm going to plug in, switch back to blue. So I'm going to plug in my x2 and my x1. So that's here and here. So x2 is 3. So I'm going to draw my big square root symbol. And I'm going to have 3 minus, and then my x1 is -2. So I'm going to put -2. This is probably the biggest mistake kids make right here, is distance formula starts off as minus, but then sometimes we have to plug in a negative. So we'll talk about what happens there. And now I have y2, which is here. So that's -5 minus y1, which is here, 0. And it's squared. So that's what it looks like when you plug it in. Then we carefully simplify one step at a time. So right here, this minus and negative becomes positive. So that really is 3 plus 2, which is 5. And then I have -5 minus 0, which is -5. Okay, now we're going to square both of them. So we're multiplying it by itself. So 5 squared is positive 25. And then -5 squared is also positive 25. That's another big mistake kids make, is they'll put -25. You want to be careful. Negative times a negative is a positive. So this turns into the square root of 50, which if you put that in your calculator, you could leave it like that, square root of 50 if you wanted to, but if you do put it in your calculator, it's about 7.07. If anyone has questions about how to put that in a calculator, just feel free to ask me. Okay, I always like to round to the nearest hundredth, which is 2 decimal points, but rounding isn't really that big of a deal. I'm going to do one more distance, and then we're going to do some midpoint. Okay, so again, here's my x1, y1, my x2, y2. Here's my formula, x2 minus x1 squared plus y2 minus y1 squared. Okay, so now I'm just going to plug in. So I'm going to do my big square root symbol. x2 is -5 minus x1 is 4, and that's squared, plus y2 is 8 minus 0. Notice every time I'm drawing the big square root symbol, you should be doing the same. Okay, so -9 minus 4, I just said the answer. -5 minus 4 is -9. 8 minus 0 is 8. So I'm going to continue this over here. So -9 squared is positive 81. 8 squared is positive 64. And if we add those two together, we get the square root of 145, which is a little over 12. So it's approximately 12.04. But again, you could leave it like this if you don't have a calculator or don't know how to find it for now. That's fine. All right, so that's how we find the length of a segment on the coordinate plane. Sometimes it's worded as find the distance between the 2 points and they're on the coordinate plane. But either way, it's the same thing. It's just distance formula. Okay, so the next thing we're going to learn about is called the midpoint formula. But first we need to talk about what a midpoint even is. So the definition of a midpoint, it's the exact middle point of a segment. So if an entire segment was 10 centimeters, the midpoint would be at 5 centimeters. So we can just say the exact middle point of the segment. Okay, so to show you an example, say we have this segment A, B, and then say we have a C in the middle. If I said C is the midpoint, I'm going to put MP to abbreviate, then that would mean that AC is congruent to CB. So I could mark them as equal to each other. So like I said before, if AB was 10 centimeters, then AC would be 5 and CB would be 5. So sometimes we're asked to find the midpoint of a segment on the coordinate plane. And so just like the distance formula, the midpoint formula uses x1, y1, x2, y2 as labels for the points, and you just plug them in. You add the x's divide by 2, and then it's a comma, add the y's divide by 2. So your answer is a coordinate because we're on the coordinate plane. So it's an ordered pair. Okay, so first thing you want to do is label your endpoint. So this is going to be x1 and y1, and this will be x2, y2. The order doesn't matter that you label them in. So if you wanted u to be x1, y1 and t to be x2, y2, that's fine too. I'm going to rewrite the formula for us so we have it right above where we're going to plug it in. Okay, and then you just plug in the numbers. So I'm going to plug in x1 plus x2, so it's going to be negative 2 plus 8 over 2. And then y1, 4 plus 10 over 2. Once you plug it in, you're going to add the numerator. So negative 2 plus 8 is 6. 4 plus 10 is 14. And then you reduce. So this is going to be 3, 7 is going to be our midpoint. So that's what you do. That's just a regular midpoint formula. You're given 2 endpoints and you're asked to find the midpoint. The next example, we have to work backwards a little bit. We are given an endpoint and we're given the midpoint and we have to find the other endpoint. So see how it says this is the midpoint, this is one endpoint, and then what are the coordinates of the other endpoint? So there are a few different ways you can do this. There's one super easy way, and then there is a more algebraic way. So I'm going to show you both. So if you want to visualize it here, let's say here's J. Now this is not actually where they would be on the coordinate plane. I'm just kind of like sketching here just to show you a visual. You could actually plot it if you wanted to on the coordinate plane. Okay, and now this is R. We don't know where R is. And so since W is right in the middle, what you can do is you can just count how many units it is from J to W. And what I mean by that is you do one variable at a time. So you just do the X's. So from 3 to 4, you want to think about like, how did I get from 3 to 4? Did I add? Did I subtract? To get from 3 to 4, you would add 1, right? So that means over here for our R, to get from 4 to this X value, you're also going to add 1. So 4 plus 1 is 5. See how 4 is right in between 3 and 5? It's going to be the same thing with the y values. So from negative 4 to negative 6, how do I get from negative 4 to negative 6? You subtract 2, right? So now from negative 6 to this one, we're also going to subtract 2. So negative 6 minus 2 is going to be negative 8. So that means your final answer here is that R is at 5, negative 8. And if we were to plot these on the coordinate plane, you would see that it is in fact in the center. I'm not going to fully do out the other method because most of you probably won't use it, but I'll just show you real fast. What you can do is you can set up a little equation for each one. So like this is x1, this is y1, r is x2, y2. And so you would just set up x1 plus x2, so 3 plus, we don't know x2, right, over 2. If we were to simplify that, that would give us the x coordinate of the midpoint. So then if you solved this for x, multiply by 2, subtract 3, you would end up getting 5. And then you do the same thing for the y value. So you would have y1, which is negative 4, plus y2. We don't know what that is, so we're just going to write y2. And that would give us the y value of the other endpoint. I mean, the y value of the midpoint, which is negative 6. So then if we solved that equation for y2, you would get negative 8. You'd multiply both sides by 2, get negative 12, add 4, and you get negative 8. So that's a more algebraic way to do it. Okay, so that's midpoint formula. The last thing we're going to talk about in this video is segment addition postulate. So segment addition just tells us that if we have a segment with multiple segments in it, like this one, see how it says if Q is between P and R, so Q is in the middle somewhere, not necessarily directly in the middle. It doesn't quite say it's a midpoint. It's just saying it's somewhere in the middle. Then PQ, so the small segment, plus QR, the other small segment, would equal the big segment. So let's just say PQ is 3, QR is 4. I'm just making this up. Then what would PR be? 3 plus 4. It would be 7. That's all segment addition is. It can get a little more complicated than that, but that's the basics of segment addition postulate. So to see this example here, H is between G and I. So let's draw a picture to represent this situation. G, I don't know where H is. I'm just going to stick it here. Then we're given that GH is 2 and then times the sum of x and 1 time, and then HI is 3 times the difference of x and 1. And then it says GI, the whole thing, is 24. So the directions here are asking us to find x, GH, and HI. So what we're going to do is we're going to set up an equation to represent the situation. We do this a lot in geometry. So we just learned this rule, segment addition. And so now we're going to use what we know about the picture to write an equation. And so what that looks like is we're going to have GH plus HI, and we're going to set it equal to 24. And then you solve. So it looks like this. 2 times x plus 1 in parentheses plus 3 times x minus 1 equals 24. See how this represents segment addition? This is GH, this is HI, this is GI. So small plus small equals big. And then you just solve for x. So I'm going to distribute here. So you're going to have 2x plus 2, then 3x minus 3. Let's combine like terms. So we're going to have 5x minus 1. So if we add 1, divide by 5, you end up getting x is 5. So we did the first part. It says find x. Now it says also find GH and HI. So how we find GH and HI is we just found down here that x was 5. So now we're going to do what's called plug it in. We're going to plug in 5 in for x. So see right here. So it's going to be 2, and then instead of x, we're plugging in 5, right? Because we just found x was 5. So 5, we'll do parentheses first. 5 plus 1 is 6. 6 times 2 is 12. And then for the other one, we're going to have 3, and then instead of x, we're putting in a 5. 5 minus 1 is 4. 4 times 3 is 12. So since GH and HI ended up being equal, that does mean that H is the midpoint, but we didn't know that going into it. So this was the only way that we could have solved it because we didn't know that H was going to end up being the midpoint. So that's segment addition. You take all the small little pieces and you add them together and set it equal to the big piece. So that is it for this lesson. Please let me know if you have questions about anything, and we'll do more of these next time as well. All right. Thank you guys.